in words and then symbolically. In words and then symbolically. So this is parallel then, or letter D. Any questions on that? Oh,
No.
okay. All right, so the next problem here is a proof, some sort of a proof. You may have to help here a little bit with figuring out what's in the drop downs to help assist here. But we're given that P is perpendicular to Q, okay? And that Q is parallel to R. Basically, what's in the picture is what we're given. We're trying to prove that P is then perpendicular to R, right? So to do that, we have to start with reasons here, reasons. What is the first reason always in a proof?
Given.
Given, yeah, it's given. All right. Now, angle 1 is a right angle. Okay, so they're not referring to the one on like the like where my arrow is. They're referring to this other side here.
Yeah.
What are some options in the drop down? Because I don't know what to even suggest here.
Definition of right angles
Okay.
is
Anything else?
substitution. Definition of congruent angles. Definition of perpendicular lines and corresponding angles
There you
positive.
go. There it is. There it is. Okay. So because P is perpendicular to Q, it's not just that this one on the right is 90 degrees, the one on the left is also 90 degrees. And it tends to always be the definition of whatever it is that perpendicular lines, I think you said.
Yeah.
Right. So the measure of angle 1 is 90 degrees. So if it's a right angle, then its measure is 90 degrees. Like one leads to the next. It's now like the definition of a right angle or something about an angle measure of a right angle is 90 degrees. Is anything
Yeah.
like that there?
Definition of right angles.
There you go. I like that. And you can start to see the pattern here that it tends to come from the previous one, like that. This one led to that one. Now four is actually from up there. Four is what we're starting with, so it is also a given. Is that okay?
Yeah.
Sometimes the givens go in the beginning, sometimes you get one thrown in later on in the proof. Okay. So now since the two lines are parallel, they're saying, oh, angle 1 is congruent to angle 2. There's a word for those two angles. Like there's a reason they're congruent. It's not because they're parallel, it's because when they're parallel, blank are congruent. Do you remember that wording? And so you can maybe click on the drop down to see if you can remember what that is. I think that's something we worked on last time.
Um, definition of congruent angles.
They have a specific name. Like I have an example here. Like one, let me just do this. 3 and 4 are considered alternate interior angles. Okay, but 1 and 2 are not alternate interior angles or something else. Do you remember what they're called?
Oh, corresponding.
Corresponding angles. So corresponding angles are congruent. All right, now if the angles are congruent, so 5 leads to 6. If the angles are congruent, what do we know about the measures? The measures must also be
Uh, uh,
not
corresponding.
they're equal. They're equal. Like if they're
Yeah.
congruent, that means they have the same measure. But there's something in there like congruent angles have the same measure. Okay, is that all right?
Yeah.
All right, so now to do 7, you're going to focus on, let me grab it here, draw. Okay, this one and this one and this one. Can you see a path from 3, 6 to 7, something in there that allows you to say that?
Um, uh,
I
definition
tried.
of right angles.
Okay, we've already done used that one. Probably not going to use it again. For number 3, though, what is number 3 saying? What tell me just in your own words what that means.
Measure one is a right angle.
90 degrees. No,
90.
measure of angle 1 is 90 degrees. You got to be more specific. And then what did 6 say?
Measure of angle one and measure of angle two are equal.
Okay, so if measure of angle 1 is 90, what is the measure of angle 2?
Also 90.
It's also 90. So it's like you're replacing what was for angle 1. This 90 degrees is going where this measure of angle 1 goes.
Is that substitution?
Yes. All right. Now 8 is kind of could be definition of right angles, could also be like converse of definition of right angles. What is 8? Is there a definition or converse or what do you see there in the drop down?
Uh, there's definition of right angles, definition of congruent angles,
Anything
and
with the word
definition.
converse in it?
No.
Okay. Because the problem is like we can't it doesn't work backwards like there, but maybe that's why your teacher's doing it. Like if it's a right angle, that means its measure is 90. So if its measure is 90, yeah, that's a right angle, but it's typically by what's called the converse. Let's just go with definition of right angles. Uh, so then this one would be going backwards, kind of again, like backwards from what? From 1 to 2 is definition of perpendicular lines. So 8 to 9 is going backwards on that. It's also definition of probably of perpendicular. Do you get feedback on this right away?
Uh, yeah, usually.
I know it says you got a couple of attempts left. Does it check the whole thing or just the ones you've tried?
Just the ones I've tried.
Okay. If you want, you could let me know if there's any issues here. I need to step away for 30 seconds anyway. Um, if not, we'll just go on to number 2, but I'll be right back. All right. Do we on to number 2 or any feedback on that?
No, it's all good.
All right, name the shortest segment from P to LB. So here's P, here's L, LB. I guess I gotta highlight that in red. Uh, that is called, when you drop straight down, that's called an altitude. Okay. So straight down is called an altitude.
Okay.
Now, I don't know what's in the drop down. It may just be the segment PA,
Yeah.
or it may say altitude PA.
Yeah. Segment PA. Yeah.
All right, write and solve an inequality for X. Okay. So X right here, this hypotenuse has to be larger than this side right here. So we have to say that X minus 6 has to be greater than 20. And it's always the case that the hypotenuse, which is the largest side of the triangle, has to be longer than any of the other sides. And so to solve this, you're just going to move this to the other side by adding 6 to both sides. Um,
26.
yeah. So X is greater than 26. Hopefully that's there in the drop downs.
Yeah.
Any questions on that?
No.
Okay, looks like 3 is approved. Looks like 4 is approved. So we're definitely going to get through both of these with some time to spare. So maybe start thinking about some other things you'd like us to work on, or I'm happy to find more stuff as well.
Okay.
All right, so this is another proof. This one is not as helpful as the last one. You have to supply all the statements. The best thing here, though, I guess, is that there's 2 givens. So you already kind of know that it's going to be angle 1 congruent to angle 2. I guess you know how you know that that's the first one, but we'll just go with that one. Um, we're trying to prove that M is perpendicular to N. Okay, so if angle 1 is congruent to angle 2, and that's given, we know that I don't think that's the first one. I'm at a little bit of a loss here because it's like I don't know what,
Is that
maybe it
too
doesn't
few
matter.
steps?
Yeah, because it's kind of like the last one we did, but we're basically like, okay, L is perpendicular to M. So we know that actually I guess I maybe want to start with that one. Uh, but okay. So if they're perpendicular, that means um that the measure of angle 1 is 90 degrees, or angle 1 is a 90-degree angle. Is that a right angle? Is there anything like that in the drop down there?
Uh, No, hold on. So there's line N is perpendicular to line
We're talking about over
one.
in this on the statement side.
Yeah, and then line one is parallel to line M, and angle one is congruent to angle two, and
Okay.
line M is perpendicular to
So
line N.
this is for sure the last one. The last, whatever you're
Yeah.
proving always goes in the last step here. Um, boy, I guess that leads to that by, um, I hate to have you check, but I kind of want to know which one is first, if it's this one or this one, but, uh, uh,
I'll
yeah,
see.
it's pretty tough for me to,
Uh, they're swapped. Um,
so they're saying that, all right, so this is angle one congruent to angle two, and this is L perpendicular to N.
yeah.
Okay, since angle one is congruent to angle two is given, that means that, what are some of the reasons over here that we can,
Um, okay, so converse of corresponding angles theorem. Per,
that's
let's see.
probably this one down here, because
Yeah.
that's what leads you to, but
There is transitive property of congruence, definition of linear pairs, corresponding angles theorem, um, perpendicular transversal theorem. Is that
um maybe we just need to say that they're the lines are, is there that the lines are parallel, L parallel to M or M? Is that a possibility?
yeah?
Okay. So if the angles are congruent, then we can say the lines are parallel. That means that if the lines are parallel, because the other given is that it's perpendicular, that means the other one's perpendicular. Okay, that's reasonable to me. So is there like a something with parallel lines over here, a converse of?
Um, Converse of corresponding angles theorem. Is that
Yes,
no?
there you go.
Oh.
Because they are corresponding. And then it's like, for this other one, I don't know. Wait, I guess I need to know what the drop downs are again. Hard to,
Uh, Perpendicular transversal theorem.
that sounds
Uh,
pretty good.
yeah.
What's another option?
Transitive property of congruence.
Might be that one, but I don't know.
Definition of linear pairs.
Nope. Because they're not, that doesn't apply because they're not like together. If they were together, it would be that.
Corresponding angles theorem.
They are not responding. So they're two lines.
Uh, Converse of corresponding angles
I already
would
used
be
that
the
one. So let's go back to
same.
that. Let's go back to that first one you had.
Perpendicular transversal theorem.
Yeah, why don't you try that?
Okay. Yeah.
But sometimes when you're stuck, we kind of got here, you just have to go through the ones that have the most reasonableness because they have kind of the word that's matching with what's going on there. Is that okay? Before we move
Yeah.
on to four? Okay. Four. All right, so four here. Given M is parallel to N, so we're gonna put that here. Okay. So the lines are parallel, that's given. And we know the prove is going to go down here. And then the other given is going to go there. So at least we're somewhat of the direction of getting the right answer. Is that okay so far?
Yeah.
All right, so if the lines are parallel, uh, you can say that, for example, angle 2 is congruent to angle 3. Is that possibly a drop down here?
Um, let's see, number two. Yeah.
No, the only reason I'm sort of going for that is because they're labeled in the drawing, like that. I don't have any other reason. And then they are corresponding angles.
Yeah.
So the way that I'm going, or the direction I'm going with this one is okay. Uh, M is parallel to N, okay, given 2 to 3 corresponding 1 to 3. So we can probably say something about angle 2 and angle 1 being congruent. I don't know if that's an option. There's angle 1 congruent to angle 2.
Uh, yeah.
So that's a transitive, or a substitution. Probably a substitution.
Yeah.
Okay. Right. So if those two angles are congruent, that means that um, the only way they can be congruent if they're on as a linear pair is if they're both 90. So there's something here that says that the two angles, um, if they're congruent, their angle measure must be 90 degrees. And so I don't know what you see in the second to last drop down, like something about the angle measure, measure of angle 1 must be 90 degrees, or measure of angle 2, 90 degrees, something like that.
Uh, yeah.
Okay. And that means they're perpendicular to M because of the con. So that this is like, I don't know what the drop down is for this one on the right either. Next to it, it's probably something to do with, hey, the angles are 90, or if they're congruent and they're on a line, they must form a 90-degree angle. Anything like that there?
Uh, yeah. If two lines intersect to form congruent linear pairs,
Yeah,
the
that sounds
lines
right.
are perpendicular.
So that's this last one.
Uh,
That's for this last one for sure. One before it, Something about since the two angles are congruent, they form a linear pair. Or maybe you just try it in both, and one of them works out.
I'll see. No, it's is it perpendicular transversal theorem?
Okay, try that.
Yeah. I ran out of checks.
Hopefully
I'll
that's
never
okay.
know. Corresponding angles theorem.
Oh, maybe. Well, I don't know. I don't really know what to suggest. It's really kind of tough. Is this right? Were all these right on the left?
Yeah.
Like the reason that they're 90 is because the other angle is 90. So maybe it is maybe it's a transitive. I'm not sure. Or converse of definition of right angles.
Yeah, it might be transitive. Yeah.
Okay. So that takes care of that one. You can see these are tough to do, especially uh, just when you don't really know the direction they're going. But do you want do you want me to find some problems? Or
Uh
or
yeah.
do you have some more that you want us to do? Okay,
Now can you find
sure,
some or other?
sure. You're gonna get a proof. You're gonna get a proof or proofs on your tests.
Yeah.
Let's see, you guys are transversal proofs. Oh, these are way, this is way too much. All right, I'm trying to find some that aren't extremely difficult. To sort of warm up on. Boy. Okay, let's try. Let's go back to some that we were kind of doing earlier. Actually, this one refers to this picture. Okay, here we go. Uh, Here's the picture. Two lines that appear to be parallel. They're giving you angles 1, 2, and 3. This one, they're giving you some angle measures. They're telling you the measure of angle 1 is 53. The measure of angle 2 is 127, and you're proving that the lines are parallel. Okay. So they give you the statements. might be a question to ask your instructor, will you give us the statements, or we're gonna have to fill in both the statements and the reasons, or some of both? What is the first reason in this proof?
Uh, given.
Given, yes. We always have to get that one right there, given. Okay. It's, we're seeing this, like, usually step one leads to step two. There, but not necessarily. So notice step two uses measure of angle 3 and measure of angle 2. So that does not the true, that does not apply here. Like 2 is its own independent step. So what why is it that measure of angle 3 and measure of angle 2 equal 180? Like, what is it about those two angles that
They are the they they add up to
they have to 180? What is it like? What is it about them? And this is maybe the better picture. It's like, imagine that that's 3 and that's 2. Like, why do they? Um,
their next. There's the the word for it. There's a word for it. Um,
it's like Wheel of Fortune, but without all the letters coming at you.
yeah.
Um, Give me some of the words that you're thinking of. That could help. Um,
Um, they're not equal. They add up to 180.
okay,
Um,
so they are
they're on the
two.
same side.
So it's like a definition of a linear pair, or because we know the angle measure, we can say that they are supplementary angles. Definition of supplementary angles.
That's the thing.
Yes.
Supplementary is the thing. The word.
Okay. So now that you've got that kind of down, um, what is the difference between line 2 and line 3?
Um, 127 is
Now, where did that come from?
presumably, yeah, it is
Okay.
the
So what's the word to say when you,
no.
yes, substitution.
Oh, okay. I was like, that's too easy.
It's sometimes best to go with the first choice here. Now, what's the difference between line 3 and line 4? Like, what do you notice as the kind of the result of it?
Hmm. Uh, measure of the 53 is the same as the first one.
But it's from line 3 to line 4, though.
Oh, um, it's the measure of angle 3.
So yeah, we're
Yeah,
overcomplicating this. Like, if you subtract 127 from both sides, you get 53.
yeah.
So to me, it's just like a subtraction property. Now, the next one, this is so tough. This next one is based on that this one, and this one. So five it comes from 1 and 3.
It's now that both of the measures have been found in their degrees. It's
Yeah, so
the
something, if you don't know the
yeah
right one, same angle measures the same. So they must be congruent. And like, if you don't know what to write, just start writing words like that. Be descriptive. Imagine you're telling a story.
The story of the angle measures.
Yeah. Yeah. All right. So 6, since angles 1 and 3 are the same, those are corresponding angles, but you don't know that they're corresponding because you don't know that they're parallel. So whenever you go backwards, it's converse of corresponding angles. So if the lines were parallel, then these would be corresponding angles and they'd be congruent. Since we've proven that they're congruent and they're corresponding, the lines must be parallel. So whenever you go backwards, that's a converse. So just because we don't have a ton of time here, let's just do a couple of solving here, or at least maybe go to one. Okay, so assume that the lines are parallel. A is parallel to B.
Yeah.
And I'm going to put some letters in here. So A, B, C, and D. Okay. X right here is the same as what angle measure? A, B, C, or D, or more than one of the above.
C.
Okay, it's by C by what? What's the reason that these are the same?
Um. Course.
Corresponding.
Correspondent.
Good. Corresponding. All right. And why is X the same as B? Why are those the same? That's another one.
It's it's on.
They're vertical. These are
Yeah.
vertical angles. Okay. Just trying to get your vocabulary up. Now, why are B and C the same?
Um. Same. No. Alternate interior,
It's
which
very good.
is
Alternate interiors. Yeah. So you got to know all those. You got to know all those. All right. So since X is the same as C, T is the same as this 2X minus 20. So you can set X equal to 2X minus 120. You solve for X, please.
sure. 120.
Okay. How did you come up with that?
The,
Tell me what you did first. Just curious. Just want to know what you did. I'm not saying you're wrong.
uh, put the 2x on the other side
Okay.
with subtraction. I got minus x
Good.
goes to 120.
Okay. Very good. Now, last question before we close out here. Be really quick. It's going to be the same picture. So if X equals 120, can you tell me the measure of angle Y? What is the measure of angle Y?
Um,
What does X plus
60.
Y add up to? Yeah, it ends up being 60 because of the fact that they add up. They are a linear pair. Linear pair. Okay, good job. We are all out of time for today, which means